Hey everyone. Today we're going to be going over the AP Comp Sci free response question 2024, question 4. So this question involves a path through a two-dimensional array of integers, where the path is based on the values of the elements in the array. When an element of the 2D array is accessed, the first index is used to specify the row, and the second index is used to specify the column. And the following location class represents a row and column position in the 2D array. Okay, so this class right here, this location class is basically all it is just like a wrapper around like an index into the 2D array. So I'm going to go ahead and just create this class real quick. Hopefully it lets me paste. Sometimes it doesn't. So actually, I guess I could just write this real quick. Private int the row, oops, row private int call. And it's going to have a constructor location. It's going to take in a row and a call, and it's just going to set the row to be what's passed in, and the call in the exact same way. Oh, and it's going to have some getters for both. Get the row. So it's going to return oops, the row, and gonna have and get the call, which is gonna return the call, just like that. Cool. And then we're gonna have a grid path class. It's gonna have an attribute, a double array attribute, a double array of ints called grid. It's going to have this method, public location, get next location, takes in a row and a call, and it's going to have a sumPath method. So before we actually jump into what those methods do, let's just write the outline of this class so we have something to work with. So GridPath is going to have double array of ints, grid, and it says the constructor or whatever, initializing the constructor with distinct values to never change. It doesn't actually ask you to write it, but we might not need to write it to actually run this. So, but that's not part of the question. So get next location is the method that we actually have to write to get points on the test, pin row, and call. So let's return null for a sec to get that not complaining, or the compiler not complaining. Some path, which is also going to take in a row and a call. And for now, let's just return 0 here. Okay. So what getNextLocation is going to do is, which returns a location object that represents the smaller of the two neighbors of the grid element at row call, according to the following rules. Neighbors that are considered are the element below the given element and the element to the right. So for example, for 9, it would, if we're looking at 9, it would want to consider 20 and 15. And if both elements exist, we want to return the smaller one. So in this case, we would want to return 15. The location object we'd want to return would be the one corresponding to this 15. So it'd have the row set to 2 and the call set to 3. Similarly, so if it doesn't have a bottom, but it has a right, we want to return the element to the right. And if it's, so for example, this 30, it doesn't have anything below, but it has something to the right. So it would return the location object corresponding to 25. And then for this 0, there's nothing to the right. So we'd want to return the location object corresponding to this 1. So, okay. And we're also promised that we're never passed in the absolute bottom right element. So we don't have to worry about that particular case. Cool. So to get started, let's create a couple of variables called last call or last roll, which is going to be stack grid length, and last call, which is going to be last this grid dot 0 dot length. Oh, and these have to be -1s because remember 0-based indexing. So last row and the last column are actually not the length. It's the length -1. Cool. So if the row so if the row that we're passed in is less than the last row, and the column is less than the last column, then we know that we have two neighbors. Bottom, so we have bottom and right. Else, if row is less than last row, then that means we just only have a bottom, only bottom neighbor. And otherwise, we know we only have a right neighbor. So if we only have a right neighbor, what we want to do is return the location corresponding to the index to the right. So that would be the same row, and the column would just be increased by 1. If we only have the bottom, then we want to return this basically a row below, and the column stays the same. Now, if we have 2, then we have to compare the value. So let's call the bottom is equal to this dot grid row plus 1, row plus 1 call, and right is equal to this dot grid row call plus 1, just like that. And if bottom is less than right, then we want to return the bottom. So we can do this. Else, we want to return the index of the neighbor to the right. So we do that. Cool. And now let's go ahead and look at the sumPath method. Right, the sumPath method, which returns the sum of all values on a path in the grid. Path begins with the element at row column and is determined by successive calls to get next location. Path ends when the element in the last row and the last column of the grid is reached. Okay, so basically what we want to do is if we're passed in 1, 1 here, we want to add that to our sum counter and then find the next location. So it's going to choose between 22 and 2. It's going to choose 2. And then we're going to add 2 to our counter. So then we're going to be at 5. And then we're going to choose between 33 and 9 by making a call to get next location, which will choose 9 and so on until we get to that last bottom right element. So let's start with a counter variable called sum. And again, let's use let's copy these last row, last column helper attributes or helper variables, sorry. So while either the row is less than last row or column is less than the last column is when we want to actually keep going, iterate. So we're going to add the sum at the current. Actually, what we're going to do is instead of using this row and this column, I'm going to create some new variables called current row. So I'm going to start that at row, and I'm going to call this current call, start that at call. So this current row and current column, they represent where we are at in our path. So initially we're at like 1, 1. And then so we're going to add the sum. So we're going to add the sum at 1, 1. So that would just be this dot grid row, current row, current row, current call. And then what we're going to do is we're going to say we're going to find the next location by calling our method that we've already written, which is getNextLocation, getNextLocation, and we're going to pass in the current row we're at, the current column we're at. And then we're just going to set our current row equal to whatever that location object, whatever the next location object that is returned. We're just going to update our row and column to be the values, the whichever index get next location return, that's what we're going to update our indices to be. So our row and column to be. And then, so once we exit this while loop, that means that now we have that current row. So that means current row is equal to the last row, and current call is equal to last call. So that means we just need to increment our sum with the last, the bottom right cell. We're just gonna do sum equals sum plus this dot grid. We could use either current row or last row, either current call or last call, but I'm just gonna keep this syntax consistent, and we're just gonna return this sum. Okay, we can test this out real quick by writing a driver. So public static main string args, and I'm going to put in a quick constructor in here to actually initialize this. So public grid path, take in double array grid, this dot grid is going to be equal to the grid. So now I can just initialize a double array grid, something like this, and let's do this one, 12, 30, 40, 25, 5. 12, 30, 40, 25, 5. 11, 3, 22, 15, 43. 11, 3, 22, 15, 43. 3, 7, 2, 9, 4, 0. 7, 2, 9, 4, 0. 8, 33, 18, 6, 1. 8, 33, 18, 6, 1. 2, 6, 1. Cool. So that's going to be the grid that I'm going to pass into my grid path. GP, this new grid path, pass in this grid. And then I'm going to call, so the sumPath is going to be gp.sumPath. And let's call the same one that they did. So they called 1, 1, 1, 1. And I'm just going to print out sumPath. And hopefully this is 9. Cool. Oops, this needs there we go. And there we go.